rocketry and gives other advantages. A 3,700-mile long cable hanging down from Phobos will fly just above the atmosphere of Mars at about 1,200 miles an hour. That's less than 7% of what we need to get to Leo. So you have something that you have characteristics more like a truck that's incredibly reusable instead of what we think of as rocketry. Yeah, if the cable is made of a pretty good Kevlar, it'll be able to pick up its own weight in. You might have a climber, so it might take a little bit more weight, but even still, it simplifies both landing and taking off. If you're just above the atmosphere and you drop your payload at 1,200 miles an hour, you can open up a parachute at those velocities in the upper atmosphere of Mars, and that'll be enough to bring you down. If you have something like a parasail, you could probably even land once the ground is prepared a little bit. I mean, we could use, there are other if we turn the same cable around, point it up instead, it can sling to an Earth intercept orbit with no need for fuel, except maybe a tiny bit to do mid-course correction. I mean, you'd have to have enough fuel if you want to stay in Earth orbit to round out your perigee, or no, you'd probably skim the upper atmosphere of Earth, and so you'd need an apogee burn after you've burned off most of your velocity coming into Earth. If it's manned, you don't want to go through the atmosphere very many times, but for freight, you can skim through the upper atmospheres a number of times before you round out your orbit with your apogee burn. Converting all that carbon dioxide to oxygen will take a lot longer. But with lots of power and very high levels of light, this can happen much faster than most plans. Within just a few years, there could be enough carbon dioxide released into the atmosphere to no longer need the pressurized suits. Very modest greenhouse pressures can be used even before then. The domes will be so much cheaper because you don't have to contain the pressure, and you can keep in a very pure, nearly pure oxygen and nitrogen. Most of these inhabit nearly, we could have some much earlier with that are primarily, there's some things you could have that don't need hardly any pressure at all, but they're not as easy to work in, and they're not as automatic. Similar factories to the greenhouse gases could produce plastics for domes. As plants grow in domes, there will be need for oxygen. They will release oxygen into the air, and most need very little. With the oxygen released from the domes, and some industrial production release, and some kinds of outside plants will bring the oxygen level up to where most plants and even big trees can grow outside. We might need to develop trees that can fix their own nitrogen in very low partial pressure. We But we may need to divert some nitrogen from comets, but there are indications that there are probably deep beds of nitrogen that we can release. So we might have to add significant heat to those beds. We don't know where they are yet, but there's strong evidence that they're there. Normally, once a tree dies, as the tree drops bark and limbs and stuff and decays, the carbon dioxide is released back into the atmosphere. So we want to grow very large trees once we have enough. I live in California. We have giant sequoia and the coastal redwoods that can tie up incredible amounts of carbon dioxide. In the higher levels of carbon dioxide, the plants will grow much faster. There's a lot of evidence to show that plants are really starved for carbon dioxide. And I want to put quite a bit of extra heat on the poles on the oceans where to help push water in the water cycle to water the plants and cause rainfall, because that's where much of the water will tend to collect, and that'll cause plankton to grow, and we'll be able to grow fish too, once we have enough oxygen there. Anyway, we could, once we've started doing this, we can start to, once we've built these factories, we can start doing the O'Neill dream of monster outer space settlements. But first we have to develop these. Much of this could be done using asteroids, and if that's our only option, I would work that way. But I think it's more fault tolerant. We're much more flexible if we're also developing a settlement on Mars at the same time. And if Earth is really getting too hot, we can easily afford to spend a few minutes production and send off a few solar cells to the Earth-Sun L2 point and lower the amount of heat hitting Earth. Anyway, terraforming
James,
the next planet.
James, just a minute.
Am I taking too long?
No, if anyone is leaving on the tour, you got about 2 or 3 minutes to go to the lobby. If you go to the tour for Carolyn Park. Okay, I didn't hear about the tour.
Yeah,
and James, you got 2 or 3 minutes officially, but no one's after you.
Okay. Anyway, there are some other incredible potentials for doing this project. Of course, Mars, Earth, global cooling or heating, massive miles across L5 O'Neill habitats become practical. We'll have enough energy to bring Earth humans up to U.S. and wealthy European style with no nuclear or fossil fuels, 250 terawatts laser pushing on a 200-ton light sail, pulling a 100-ton craft, can accelerate at 1 gravity. So Earth-Moon travel is in just a few hours. Earth-Mars in a few days. Half the speed of light in 6 months. We could be living around other star systems within a half century. Warp drive? I don't know. I don't know if that's ever possible. We have no idea how to get to other stars faster than light or even very close to the speed of light. But we could settle the galaxy in about half half a light speed. And desire is to where's that? Huh. Anyway. Thank you. Any questions?
I appreciate that somebody actually did a show again on terraforming, because it's one of my favorite topics. And although for practical reasons, I'm focusing a lot on current events and things that are of immediate necessity to develop, we need to keep our eyes on the mountaintop as well as on the path up the mountain. So one of the issues that I look at and Ed looks at is I think the concept of using phobos materials as a leverage to build things like film and so on is a good strategy. But you have to look at the fact that we don't have any actual phobos material yet. The next Russian mission is going to try to bring some back, so we might have a better idea of what it's composed of. The average asteroid is not an iron asteroid, and if it's not pure iron, then you have only a relatively small percentage of iron in the typical asteroid.
And part of the reason why I did my processing is to separate, boil off the volatiles, separate the metals from non. There's a lot of evidence that, and especially the, there's one expert that has done a lot of work on utilizing outer space resources, and he has he's shown that the average non-differentiated asteroid cometary material has grains of iron type metals and grains of silicon aluminum oxide primarily, and if you just separate the two, you can get almost a very high iron content and almost all of your platinum group metals. I didn't talk about that, but I could, with the same equipment, I'll be the output of the if it is something like the dried out cometary carbonaceous chondrite undifferentiated, you'll also be collecting after a tiny bit more processing a dust that is basically a platinum group metals that'll be incredibly valuable on Earth. And we need those now because we're running. We don't have. There's not enough platinum group. There's not enough platinum to run all of the catalytic converters that China and India need now.
And you're right about that. It takes a lot more electricity to get aluminum than to get iron. It's absolutely true.
Thank you. Any others?
Yeah. This is kind of an off-to-the-side question, but I was wondering if there would be any other gases that could be synthesized locally on Mars that have a much higher index of holding heat into the planet than even carbon dioxide. I think I have heard, this may be wrong.
Oh yeah, no, that's why I said part of the power is going to be beamed down to the surface to feed factories that'll produce CFC type non-chlorine CFC type gases, which have a much higher greenhouse effect than carbon dioxide.
Right. Yeah,
and water is more effective much more effective greenhouse gas than carbon dioxide. But at its current level, Mars has 30 times as much carbon dioxide per square inch as Earth does, which means with those two gases and greatly increased carbon